theorem. So what does Thevenin theorem says? That if you have a linear two terminal circuit, okay, if you have a linear two terminal circuit, here linear means your circuit consists of only linear component like resistance, capacitance, inductance, whose value does not change with the current or voltage applied voltage. Okay, so suppose I have this two terminal linear network. So Thevenin theorem says that this linear network can be replaced by a voltage source called VThevenin along a resistance in a series, which is called RThevenin. For example, say here I have a resistance RL, okay, and here also I have a resistance RL. So basically, what is the meaning of this theorem? This theorem says we have a linear network, okay, which may be a complicated network, and this networks gives voltage some current value here. So across this resistance, some voltage drop RL is there, V load RL is there. Okay. Now Thevenin theorem says that you can replace this complicated circuit with this simple circuit, okay, which consists of a voltage source and a resistance in series. So basically, if this circuit is giving some voltage here, some current here, and this simple circuit also giving the same current and same voltage across the load, okay, so that means what happens, these two circuits are equivalent. Okay, so what does what does matter to us? Okay, we just want there's some fixed voltage. Okay, now whether a circuit is this or circuit is this doesn't we do not care this one. Okay, if the same circuit is giving this voltage VL here, and this circuit also giving voltage VL, which both are equal, then these two circuits are equivalent. Okay, so what is the statement? A linear two terminal circuit can be replaced by an equivalent circuit okay, consisting of a voltage source VThevenin along with a resistance RThevenin in series. Okay, so we are not proving this theorem. This theorem also can be proved, but I'm giving direct statement, and we will see the applicability of this theorem, how this helps us to simplify a complicated circuit. Okay, so shall I erase this one? So let me give you example. Okay, so I have now a circuit. Okay, so first of all, if I want to replace a circuit, just now I drawn a network. Okay, just now I drawn a network, and I told this network can be replaced by a source VThevenin and RThevenin. Okay, now if I want to replace equivalent circuit, so I need two parameters. What are these two parameters? I need VThevenin. Okay, number one, I need to calculate VThevenin, and then I need RThevenin. So how can we calculate these two parameters? So suppose if I open this circuit, okay, and I measure a open circuit voltage, okay, open circuit voltage, say this circuit is voltage is V naught, okay, or V open circuit, say this is V open voltage circuit. Now because these two circuits are equivalent, okay, so if the voltage is coming V open, so if I open this one also, I should get same voltage here. If I measure V open here, okay, these two voltage should be same. Now can you tell me how much voltage is coming here? What is the voltage here? VThevenin. Okay, because this circuit is open, so no current is flowing. Okay, so that means this in this resistance there is no drop. So whatever voltage will come here, the same voltage will be here. This terminal has same voltage. So whatever V open will be, that will be our VThevenin. Okay, so in order to measure VThevenin, we need to measure the V open of the circuit. Okay, so we need to measure V open of the circuit, or simply you can say VOC. Okay, V open of circuit, VOC you can also say. Now similarly, if I want to measure RThevenin, so what should I do? RThevenin. So suppose if I measure a resistance across this two terminals, say this is R in, okay. So when you want to measure the resistance, so that time you need to deactivate all the sources. For example, in the circuit, if there is a voltage source, you need to make this short circuit, and if there is a current source, you have to make open. So when you measure R in, okay, by making all the source deactivated, by making all the sources, okay, deactivated. So whatever resistance you will measure here, okay. So similarly, I need to deactivate also here also source, okay, and here only we have one source. So if I make this source as a short, okay. So what will be my R in? What will be my R in? So this in this case, the resistance across these two terminals is equal to RThevenin. Okay. So whatever I measure R in, okay, by making all sources deactivated, that will be my RThevenin. So let me show this method by a question.
सर सोर्सेस डीएक्टिवेटेड मींस जो करंट का सोर्स होगा वो ओपन करना पड़ेगा ना,
Current
वो डेट क्लोज ऐसे.
yes. Okay. For example, now I have a 32-volt battery, okay, and I have this 4 ohm resistance. I have one 12 ohm resistance, okay, and I have a 2 ampere current source. I have here a 1 ohm resistance, okay, and here I have a load resistance RL, okay. Now this load resistance can be anywhere, okay. Just for simplification, I am putting this load resistance at the end, but it can be anywhere. They can ask you anywhere what is the Thevenin equivalent, okay. So in this circuit, we need to find a Thevenin equivalent circuit. Thevenin's equivalent circuit, okay. Now, how can I find the Thevenin equivalent circuit? The Thevenin equivalent circuit, I need two things. Okay, number one, I need VThevenin, and number two, I need RThevenin. Okay, so first of all, what I'll do, I'll measure VThevenin, and VThevenin can be, or suppose let us first let us measure RThevenin. Okay, so how can I measure RThevenin? So if I want to measure RThevenin, I need to deactivate all the sources. First of all, I need to measure R Thevenin across this resistance R in. Okay, whatever R in I'll measure, that will be my R Thevenin. So in order to measure the resistance across these two terminals, I have to deactivate all the sources. So this become open circuit and this become my short circuit. Okay. Now I have to measure the total resistance across these two terminals. So you can see in the circuit, this 4 ohm and 12 ohms are in parallel. They are connected end to end. Okay. So if I want to write total resistance R Thevenin, that will be these two are in parallel. So 4 is parallel to 12. Okay. And there is one more resistance, say 1 ohm resistance. So whenever you want to find a equivalent resistance, okay, and you will get confused that where see the resistance are in parallel or series, okay, so you need to adopt a method. You have to assume that here a voltage source is present and this source is giving current. Okay, now this current is giving here. Now this circuit is open, so no current will follow, and again this current going here. So here current will divide. So whenever current is divide, that means those resistance are in parallel. Okay, in simple circuit. Okay, you can get idea. These two circuits are now, since current will divide here, so these circuits are not in series; they are in parallel. Similarly, if there is one more resistance here and same current is flowing in the two resistance, okay, continuation, then those resistance will be in series. Okay, so this is a simple circuit. Here you can easily identify because they are end-to-end connection. So this the equivalent of this two resistance will be these are parallel resistor, and equivalent of this will be a series of this resistance. Okay, so now I can write R Thevenin is 4, 12. Okay, 4 plus 12, 16 plus 1. So this become 1, 4. This become 3. Total become 4 ohm. Okay, so R Thevenin. Okay, I need two parameters. So R Thevenin is 4 ohm. Now we will calculate V Thevenin. Okay, so in order to calculate V Thevenin, again I need to put these sources back. So I have 32 volt battery, and I was having 2 ampere current source. Okay. Now this is very simple.
So we are having load also, no? RL.
RL. So when we measure V Thevenin, we need to measure V open. Okay. So wherever we want, because RL तो हम लास्ट में लगाएंगे ना, भी हमको इक्विवेलेंट सर्किट चाहिए, और जो भी इक्विवेलेंट सर्किट होगा उसके हम यहाँ पे हम RL लगा देंगे. तो हमको यहाँ पे इक्विवेलेंट RL लगाना नहीं है, हमको ओपन सर्किट वोल्टेज मेजर करना है. Okay. So now I want to measure V Thevenin. So V Thevenin will be your open circuit voltage. So this voltage I need to measure. Now you can see, if since this circuit is open, so no current is flowing in this terminal. Okay, so whatever voltage is here, okay, whatever voltage is at this point, that voltage is same like this V open. Okay, similarly here also no resistance, they all are, these all are short. Okay, so whatever voltage I will measure here, that will be like the same like this voltage. Okay, so there are the number of methods how you can calculate V open here. Okay, node analysis, mesh analysis, but I generally use superposition principle. Okay, so let us apply superposition principle and calculate voltage here. Okay, so superposition principle, what does we do, how we perform? So we take one source at a time. Okay, so now I'll measure, again my V will be V1 plus V2. Okay, V1 will be what? V1 will be voltage VOC1 or V open circuit voltage due to 32 volt battery. Okay, and V2 will be VOC due to 2 ampere current source, 2 ampere current source. Okay, so let us calculate first V1. Now I want V1. Okay, So V1 is same, like, because no current is flowing here, no current is flowing here. So whatever voltage will be here, that will be my V1. Are you getting what I'm saying? Whatever voltage will come here, say this voltage is V1. So the same voltage will go here because no current is flowing in 1 ohm resistance. So no voltage drop. So now what is V1 here? So V1 is simply total, if you have like KVL here, okay, so minus 32 plus 4i plus 12i, 16i. So current is 2 ampere. So I can directly write, either you write KVL, I am directly writing total voltage is 32 volts divided by total resistance 16. So I will be having 2 ampere current, okay, 2 ampere current, and this 2 ampere current when multiply with this 12 volts, this will give me V1, okay. So this 2 ampere into 12 volt, this will give me 24 volts. So my V1 is 24 volt in the circuit, okay.
Sir,
Uh,
direction of current through 1 ampere
uh,
is why it is like that? Why it is not going outward direction?
which current?
According to
This current.
no. Current in a diagram, 1 ohm resistor is there. Sorry, not current. 1 ohm resistance is there. Na? Across that we have drawn the means. हाँ, in that branch, open circuit की जो branch है, वहाँ inward जाने वाला current क्यों जा रहा है? इसमें समझ में आया इस branch में उसके 1 ohm की जो branch है ना उसमें.
ये इन्वर्ट नहीं है भाई, ये तो
हाँ,
इन्वर्ट नहीं
outward
है,
है.
ये तो कुछ है ही नहीं ना, भी ओपन है ना, सोर्स तो खाली एक ही है यहाँ पर.
हाँ.
अभी सोर्स तो एक ही है. अब यहाँ से करंट आ रहा है, वो करंट यहाँ जाके यहाँ चला जाएगा, यहाँ तो जाएगा ही नहीं, यहाँ तो जीरो, यहाँ तो ओपन है ना. तो इट्स ओपन है, तो पहले से ड्रॉ किया हुआ था साइन, ओके. देयर इज नो करंट हियर. हियर I zero, you can also write I is 0 in this branch, okay. So these two terminals are same. So this is V1, okay. So now we have V1 equals to 24 volt, okay. Now let me calculate V2. V2 will be due to 2 ampere source, 2 ampere current source. So I need to make it short, okay. Now again, because same thing, whatever here no current will go, so whatever voltage will come here, okay, the same voltage will be here. So I need to measure now voltage across this due to this 2 ampere source. So this, say this voltage is V2, okay. Now 2 ampere current, all 2 ampere current is going here, okay. Now this, there will be current division. So if I want current in 12 ohm resistance, that will be how much? Total current 2 ampere, okay. The resistance of opposite branch 4, and then algebraic sum of resistances, total resistance is 16, okay. So this is 1, this is 4, and this is 1, this is 2, okay. So 0.5 ampere current is flowing across this resistance, 12 ohm, and then V2 will be in same direction as V1, and this becomes 0.5 into 12, and this will give me 6 volt, okay. Now I want total voltage V Thevenin. So V Thevenin will be V1 plus V2, that means 24 plus 6 equals to 30 volts, okay, 30 volts, 30 volts. So now I know R Thevenin and I know V Thevenin, okay. So I can now draw the equivalent circuit of this circuit, okay. This given circuit, the equivalent circuit I can draw is, okay, 30 volts, which is V Thevenin, okay, and this R Thevenin is your 4 ohm, and across here we have a resistance RL, okay. So this is my equivalent circuit. Any doubt in this theorem? Okay.
So in V2, how we have done, sir?
What now? I have removed the circuit. Now you are asking. Tell me V2 is how we are doing. We are doing current division. 2 ampere current is coming, and that current is getting divided in 12 ohm and 4 ohm resistance. Okay, so once you know
Yes,
the
sir.
current in 12 ohm, okay, then you know current, you know resistance, you can find the voltage.
Yes, sir. Yes, sir.
So this is Thevenin. Okay, let us solve one more problem. Now this, I have solved this question with superposition principle. Okay, you can use anything, nodal analysis, mesh analysis. Okay, uh, or actually you should try, because the same question you should try with different methods. Okay, then only you understandably increase of circuit. So I have done this as superposition. You should try with nodal analysis and mesh analysis, the same question. Okay, so let me put one more problem. Say I have this a 180 volt battery. Okay, I have this 2 ampere current source. I have here one more resistance here, 60 ohm. Okay, 90 ohm, 90 ohm, and here I have, say, a 15 ohm, okay, resistance, say RL. So in question they're asking, calculate the current I flowing across 15 ohm. Okay, calculate the current flowing I through across 15 ohm. So I 15 ohm I need to calculate. Now I'm calculating using Thevenin equivalent circuit. Okay, so find I using Thevenin equivalent, Thevenin's method. So same thing with Thevenin methods, we need VThevenin and we need RThevenin. Okay, so let us first calculate RThevenin. So in order to calculate RThevenin, okay, I'm again repeating, in order to calculate RThevenin, you need to deactivate all the sources. Okay, so across this RL I want to measure. So first thing is you have to open this RL. जिसके भी अक्रॉस पूछे वहां से सर्किट को ओपन कर दो, RL कटा दो, क्योंकि that will not be part of our equivalent circuit. Now remaining circuit we need to make a equivalent circuit. Okay, now in order to measure RThevenin, deactivate all the sources. So deactivation means current source will be open and voltage source will be short. Okay, now you have to find what is the equivalent resistance between two. Okay, so suppose the current is flowing here, that current will divide here. Okay, say I current is coming and I1 will go here, I2 will go here, and the same current will flow here. That means these two resistors are in series. Okay, and equivalent of these two equivalent of this resistance, say one equivalent resistance, say 180, this 180 ohm. Now 180 ohm is now connected here. Okay, and disconnected here. That means now if you want to calculate RThevenin, so it will be your 90 plus 90, and this combination 90 plus 90 will be parallel to your 60. Okay, so now 90 plus 90 is 180, 60, this is 180 into 60 upon 240. Okay, this is 1, this is a 4, and this is a 45. Okay, so your RThevenin in this question is 45. I hope all of you are getting. Okay, now you have RThevenin. Now again you want to calculate your VThevenin. Okay, so VThevenin. Okay, again I need to put the sources. So sources was 2 ampere, and here how much source was there? What is source was there here? What is the voltage source?
180.
180 volt.
180 volt. Okay, so 180 volt is here. Okay, now you need to find V open here. Okay, V open here, V open circuit voltage, that will be your V Thevenin. Okay, and of course now I take V again equals to V1 plus V2, and V1 is due to 80 volts, 180 volts, and V2 is due to 2 amperes. So let me calculate first due to 180 volts. Okay, now when I put 180 volts, current will go here. Here there will be no current, I0. This current, whatever current is coming, that current will follow here, and again it will come here. Again it will not divide here because it is open circuit, so no current will flow here. So all the current will flow here. So same current is flowing 90 ohm, all the three across all the 3 ohms, 3 resistance. Okay, so all these three are in series, isn't it? So all the three are in series, so I can find what is the voltage across this 60 ohm. The same voltage will be VOC, or that will be my V1. Okay, so I can write now my V1 is equal to 180 total resistance, 180 to 40 into 60. Okay, so this is 1, this is 6, this is 1, this is a 4, and this 4 will go here, 4, this is 45. So this is 45 volt. V open, V1. Okay, now similarly you can calculate your V2. Okay, and to calculate V2, what should I do? I should make this short, and I should put a current source back to its position. Okay, 2 ampere. Now again this is very simple, there's no complication. You have 2 ampere current. Okay, some portion will go in this side, some portion will go in this side. Here no current will flow, so whatever current will coming here, that same current will flow here. Now these two resistance are in series. Okay, and combination of this is parallel to this resistance. Are you getting? These two resistance are series. Your current is coming here, same current flowing, and this is different. So this resistance, okay, and the combination of this resistance, let me draw for your your calculation. This is 2 ampere source. Okay, and the current is divided in two parts. One is 90 ohm here, and one is your 90 plus 60, 150 ohm. 150 ohm current, 150 ohm resistance. So I need to find the what is the current in this branch in 60 ohm. Okay, 60 ohm the current is same, black which falling in 150 ohm. So you need to apply current division. Okay, so let me apply now current division first. So current division says if you want current in some branch, say 60 ohm branch, current in 60 ohm branch will be what? Current in 60 ohm branch means you have to take opposite resistance 2 ampere, opposite resistance, and total resistance. Total resistance become 90 plus 60, 150, and 90 240. Okay, so the current will be what? 0 0 3 8 1 by 4. Okay, so current is 3 by 4 ampere, and if I want voltage, now this voltage will become V2. Okay, and V2 will become now, okay, 3 by 4 current into 60 ohm resistance. Okay, this one, this 15, 45, again V2 is also coming 45 volt. So now
Total.
yes, so VThevenin will be 90 volts total, 45 plus 45 and 90 volts, and RThevenin also we have calculated 45 ohm. Okay,
सर
हाँ
सर I62 इंटू ये मतलब करंट दोनों में डिवाइड हुआ तो
तो
2
मैंने
कैसे जाएगा 1 2 से कम जाएगा ना
तो मैंने I60 निकाला ना, I60 में कितना करंट जा रहा है, इस ब्रांच में कितना करंट जा रहा है, इस ब्रांच में करंट निकालने के लिए सामने वाली ब्रांच का रेजिस्टेंस लेते हैं,
यस सर
टोटल करंट लेते हैं, सामने वाली ब्रांच का रेजिस्टेंस लेते हैं, फिर टोटल रेजिस्टेंस लेते हैं। टोटल का मतलब ऐसा नहीं कि 60 और 90 लोगे, ब्रांच में कितना रेजिस्टेंस है वो लोगे, ब्रांच तो पैरेलल है ना।
यस सर
ओके, तो
सर
हाँ बोलिए।
मोस्टली थेवेनिन्स नेटवर्क में वो जो हमें आरएल होता है जिसके अक्रॉस हमें वीटीएच आरटीएच निकालना होता है
हाँ
वो वर्टिकल होता है, लेकिन अगर वो हॉरिजेंटल हुआ तो मतलब ऊपर के ब्रांचेस में हुआ तो कैसे ओपन करेंगे हम सर्किट?
तो उसका भी क्वेश्चन कर लेते हैं, अभी करेंगे इसके बाद नेक्स्ट। फिर उसमें क्या है, ओपन तो करना है, कैसे ओपन करो। नाउ you have this one B plus, this is your 90 volts, R Thevenin is your 45 ohm, okay, and here we have been given 15 ohm resistance. So question में क्या पूछा था कि what is I15? I15 ohm, so you can easily calculate. You have 90 volts, total become how much?
60.
60. This become 3 upon 2, okay, 1.5 ampere. So answer should come. So let me give you what she is asking. If there is a horizontal, okay, in that the circuit. So I hope this is clear. Okay. So let me give one more circuit. Say this time I have.
Voice is not clear. हेलो सर,
Yes.
सर आपकी आवाज इतनी क्लियर नहीं, थोड़ी एको हो रही है।
अभी भी हो रही है?
यस सर।
अभी पहले चल रही थी।
एक मिनट।
सर आपकी वॉइस
सर
नहीं आ
आपका
रही।
आवाज नहीं आ रही।
He's adjusting something.
Is it fine now?
Yes sir.
Yes,
यस
sir.
सर।
So say this is my 10 volt. Okay. This is 10 ohm resistance. Okay. Say this is 15 ohm resistance. Then I have say a 8 ohm resistance here. Okay. And say this is 4 ohm resistance here. And say this is 6 ohm resistance here. And say I have here 5 volt battery. Okay. Now in this question he says find the voltage across 8 ohm, current across 8 ohm. Okay, find the current across 8 ohm. Okay, now this become RL for me. Are you getting? Now because he asking current in here, so this question becomes very simple na. If I make a equivalent circuit, okay, of this after making it open, and I can attach this resistance in the series, and later I can find the current. Okay, so this question if you can solve directly, you should solve directly, but I am solving with this VThevenin. Oh, okay, so first of all, if I do VThevenin, wherever it asking current, to make that circuit is open. Okay, so this is my open circuit. Okay, now first thing is to calculate RThevenin. So RThevenin is you have to short circuit. I am making this short circuit. Okay, so I am measuring now here RThevenin. So RThevenin measure करने के लिए क्या करते हैं? You can see here these two resistance are what? Parallel end-to-end connection. Okay, so I have this resistance and then I have this parallel combination of this resistance. So 10 parallel to 12, 10 is parallel to 15. So 10, 15, and this 25. So 3, 5, 2. Okay, 6 ohm. So the total resistance of this is 6 ohm. Okay. This is 6 ohm. Okay. 6 ohm. And then if I take here 6 into 4, so 6 into 4, okay, so this will come my 10, okay, so kitna aa jayega 2.4, okay, 2.4. So this 6 and this 2.4, okay, they are not in series. If I make combination of this one, so this become total now 2.4, okay, and this is I removed. So this is 6 ohm here, this is 6 ohm, okay, and this is now 2.4 ohm, so no connection. So now these two resistance are in series, okay. So R Thevenin kitna ho gaya? So R Thevenin is your 6 plus 2.4, that is 8.4 ohm, okay. Now let me calculate V open. So here I was having, यहाँ पे कितना resistance था? What is the resistance here?
15 ohm.
15 ohm here, and voltage कितना था?
10 volts.
10 volts. 10 volts, and here I was having 6 ohm, and here 4 ohm, and the voltage was 5. I was 5.
Yes, sir.
Okay. Now just calculate. Now I want VOC. Okay. हाँ कहाँ पे 10 ohm था, 10 ohm था, 10 ohm. Okay. This was 10 ohm. Okay. Now I want VOC. VOC means if voltage here is VA and voltage is VB, so VOC कितना हो जाएगा? VA minus, okay, VOC will be VA minus VB. Now just see this circuit carefully. Suppose this, now these two circuits, okay, are disconnected. Okay, these two circuits are, now if you want you can use superposition theorem. Okay, if you make superposition theorem, so what will you first calculate VA, so you have to make this short. Let me this become short. Okay, now suppose current is starting from here, so this circuit is disconnected here, so no current flow here. So this current again go here. Now what will happen? Whether this current will divide here or not, it will not divide.
No, sir.
ये circuit यहाँ पे जो current है, ये it cannot further divide, because if it is divide, how can it reach again back to here? Okay, because this current is starting from here, so जितना current यहाँ से start हुआ है, that same current has to reach back to negative terminals. But this circuit is open here, so current cannot go here. This current is flowing here. Now this whole current will go back to here. So here current cannot go. If it goes here, this circuit is again open. So how it will come back? Okay, so that means these two circuits are totally disconnected, because once we make disconnection here, these two circuits become disconnected. So actually you can say no current is flowing in this circuit. If you use 10 volt source, then also there will be no current. If you use 5 volts source, then also there will be no current. Okay, so this is completely a different circuit, completely isolated circuit. Okay, now I want VA. So VA is calculating. VA is very simple. I want VA. I have total voltage 10 volts. Okay, divide by total resistance. Total resistance become 25 into 15. I want VA, voltage across 15 ohm. Total current is 10 divided by 25, 15. Okay, so this become now 5, this 3, okay, this 1, this 2. So VA become now 6 volt. Okay, so this is plus, this is minus. Okay, similarly, when I put a 5 volt battery here, okay, current will start here, it will come here and it will reach back to the original source. Say this voltage is VB, so VB will be how much? VB will be now, I want VB across this 4 ohm, total voltage is 5, total resistance is 10, and current is 5 by 10 into 4. So this will 1, this become 2, this become 2, this become 2 volts. Okay. Now you want VOC. VOC will be simply VA minus VB. This become my 4 volt. Okay.
Means in between there is a connection. Means there is one wire. So how they are not connected to each other?
वन वायर से सर्किट कनेक्ट नहीं होता है ना, कनेक्ट होगा तो पूरा कनेक्ट होगा, कहीं से ब्रेक कर दिया तो ब्रेक हो गया, जहाँ पे कनेक्शन है वही कनेक्टेड है, जो कंप्लीटली कनेक्टेड है वही कनेक्टेड है, एक जगह ब्रेक कर दिया तो पूरा ब्रेक हो गया, ये वाला क्वेश्चन. ठीक है. अब करंट आपका खाली यही यही घूमता रहेगा, इसीलिए इसका करंट यही घूमता रहेगा. सो दिस इज योर 4. सो नाउ आई कैन redraw a equivalent circuit. I can find the current in 8 ohm. So if I draw V Thevenin, so V Thevenin is 4 volt. R Thevenin was 8.4 or 6.4, 8.4 ohm. Okay, and your resistance was initially 8 ohm. Okay, and they were asking what is the current through this 8 ohm, I8 ohm. Okay, so I8 ohm will be 4 divided by 16.4. Okay, calculate how much is coming. So it should come 0.244 ampere. Okay, or you can write 244 milliampere. Check and tell me whether it's coming or not. Tara?
Sir, how 8.4?
8.4. Just now we have calculated R Thevenin. Previously, R Thevenin was what? R Thevenin 2.4 plus 6. We have two resistances, and we told one is two parallel resistance. They have equivalent 6, and latter is equivalent 2.4, and both were in series.
Got it, sir.
So this was your Thevenin theorem. Okay. Now in same line, there's one more theorem, Norton's theorem. Okay, I just give the statement. So Norton's theorem. So Norton theorem says that a linear two-terminal network or circuit can be replaced by an equivalent circuit consisting of a current source okay, along with a parallel resistance, a current source, say IN, right? and it along with a parallel resistance, okay, RN. So like we have replaced a voltage source is a circuit by a voltage source and series resistance, or same circuit I can replace by current source and parallel resistance. Okay, and that is source transformation. A voltage source along with the series resistance can be replaced by a current source and parallel resistance. So let me explain this theorem. Okay, so again I have this two terminal circuit Okay, linear two terminal circuit. Okay. Now here I have say a resistance RL here. Okay. Now I can replace this circuit by a simple circuit consisting of a current source called IN, okay, and a resistance parallel to this one called RN. Okay, you can again put this load here RL. Now this is simply source transformation of Thevenin's theorem. Okay, how now I'm saying this circuit is equivalent to this circuit. Okay, so first let me explain what is the meaning of this circuit. Okay, so first I need to calculate, if I want to calculate Norton equivalent, I need one thing, I need IN. Okay, and second thing I need what? I need RN. So how to calculate IN? Suppose I have a resistance RL and I remove this resistance and I put a short circuit here. That means I am shorting the load resistance. Okay, so a current will flow here due to this circuit. Say that is short circuit current. Okay, with some current will flow when I make it short. Some current will flow, and that current will be ISC. Now these two circuits are equivalent. Okay, so similarly I have to make short circuit also short. This circuit also short. Okay, so in this case, this short circuit current should be equal to this one. Okay, now what is the value of this one? What is the value of this one? So IN current is coming here. It will divide. So this is short circuit. Short circuit means zero resistance. Zero resistance means what? All the current which is coming here,
IN.
all the current will go here. Okay, because this is short circuit. That means if I want to measure the IN, so now what I should measure? I should measure ISC. ISC is what? Short circuited current. Short circuited current. Now next thing is RN. RN is same like RThevenin. You make it this circuit open and you make it measure R in. Okay, so whatever R in you measure, that will be your RN. Okay, so RN is nothing like, it is equivalent to your RThevenin. So you measure open circuit voltage, open circuit resistance, and then you measure short circuited current. Okay, you can find the Norton equivalent of this circuit. Okay, so we'll do it this later. First let me explain how this circuits, Thevenin circuits and these circuits are equivalent. Okay, so I told you that this circuit is equivalent to this one, and I also told you that this circuit is equivalent to this circuit, V plus V Thevenin, R Thevenin, RL. Okay, now if these two circuits are equivalent, these two circuits also should be equivalent. Okay, so let us prove this one. Say resistance RL is same, here is also RL, here also resistance is RL. Okay, now I am proving that these two are same. This all three are same. Okay, now say resistance is RL. Okay, now if these two circuits are equivalent, then they all should give same current in the resistance. That means the voltage drop across this should be same. So say here voltage drop is VL. Similarly here also I should get some voltage drop VL, and these two VL should be same if they are circuits are equivalent. Okay, so now if I calculate voltage here VL, this VL is simple. VL is what? V Thevenin divided by total resistance R Thevenin plus RL, okay, into RL. Are you getting what I'm doing here? These are same, okay. BL equal to B Thevenin, R Thevenin plus RL into RL, okay. So for this circuit, similarly, if I calculate BL from this circuit, okay, so how can I calculate? I need current here, RL. So in order to get current here, I need to take the resistance of opposite branch, okay. So say opposite branch is RN, total current say IN is coming, okay. I will take the resistance of opposite branch, that is RN, okay, and then total resistance is RL plus RL, RL plus RN, okay. This become current, and if I have resistance, I need to multiply by this as a again RL. Okay. Now if these two circuits are equivalent, okay, so you can see if these two circuits are equivalent, these voltage should be equivalent. That means RL is RL same. That means this R Thevenin should be equals to RN. Okay, this R Thevenin should be equals to RN, and it is we are measuring in the same way. Obviously, they are same. R Thevenin and RN are same. Okay. Now, if these two voltages are same, then your V Thevenin should be equals to your IN, RN, and RN, IN, RN are all same. So IN into R Thevenin. Okay. So if you want to calculate IN, you simply should calculate V Thevenin divided by R Thevenin. You will get IN. That means these two sources, these are two circuits are equivalent. Okay. This is called source transformation. Okay. Let me show you with example. Suppose I have a resistance, a voltage source plus say 4 volt, okay, and I have a resistance 2 ohm, and I have a resistance say RL, okay. Now this circuit I can replace. This is a Thevenin equivalent. This circuit I can replace by a Norton equivalent by simply writing I want IN. So IN is simply what? V Thevenin upon R Thevenin. So 4 upon 2. So I can make this 2 ampere source, and R Thevenin is R and RN are same. So whatever R Thevenin, I can put it here 2 ohm. Okay, and the resistance is RL. So these two circuits are equivalent. Okay. Now suppose this is a 5. Say this is 2 ohm. And say this is 2 ohm. Now I should get same voltage across this 2 ohm. You can check whether the same voltage is coming or not. Now this is a 4 ohm resistance, 4 volt. So how much will come? 1 ampere current, and 1 ampere current. This will be here will be 2 volts. Okay. Now similarly, if you do here 2 ampere current, both resistance are same. So 1 ampere current will flow. Okay. So 1 ampere current here, 1 ampere current here. So here voltage drop will be 2 volt. Okay. So both are giving same thing. So this way you can relate. If you don't interested to calculate Norton theorem, just simply calculate V Thevenin circuit, and then later you can replace this V Thevenin by Norton equivalent. Okay. So if you find a Norton equivalent is more easy compared to Thevenin equivalent, you find Norton equivalent first, and then you can later convert to your Thevenin equivalent, because both are same thing. One has a resistance in series, other has a resistance is parallel. Okay. So any doubt from today's class? And tomorrow we will learn how to calculate Norton equivalent. So I am stopping today here. Any question?
Thank you, sir. Good night, sir.
Good night.
Thank you, sir. Good night, sir.